Okay, Algebra 2 fans, our topic for today is rational exponents. After this lesson, students should be able to write expressions with rational exponents in simplest radical form and vice versa, evaluate expressions in either exponential or radical form. So before we start, let me tell you your quote of the day. This is by Kurt Vonnegut, famous author. "For those who believe in telekinesis, raise your hand." Okay, so let's start with definitions here. If a is an element of the real numbers and n is a positive integer such that the principal nth root of a exists, then a raised to the 1 over n power is the same thing as the nth root of a, and a raised to the m over n power is equal to the nth root of a to the m. So what this is telling us is that we can take a value with a fraction exponent, a rational exponent, and we can change that into radical form. So we can go from exponential to radical form. Don't mind the police siren going off down the road. Okay, as an example, if I say 8 raised to the 1/7 power, 8 raised to the 1/7, that's the same thing as the bottom of my fraction, the denominator, becomes the index of my square root. It becomes the 7th root of, in this case, 8. The 7th root of 8. Now, if we say 8 raised to the 3/7, so now your fraction, the numerator and the denominator are both numbers other than 1, what happens is that the bottom number, again, is your index, and the m is the exponent for the base. So 8 to the 3/7 is the 7th root of 8 to the 3rd, or you could write this as the 7th root of 8. If you have an exponent, you can raise that exponent, you can put it outside parentheses for that. So the 7th root of 8 cubed, or the 7th root of 8, all of that raised to the 3rd power, it's the same thing. Now, if you don't believe that this actually works, let's try an example with numbers here that we're familiar with. For example, the square root of 25, which you know is equal to 5. But you could write this is the radical form here. We can make this exponential, where that's 25 raised to the 1 over 2. The index becomes the bottom of the fraction. Now 25 to the 1/2 power, you can take the calculator, 25 to the, I'm going to put 1/2 in parentheses when I type that fraction, and notice it gives me 5. So the square root of 25 is the same as 25 to the 1/2. Let's say we take a different one. Let's say we take the 4th root of 81. Now the 4th root of 81 should give us 3, and it does. But we could change that from radical form to exponential form. That's the same thing as 81 raised to the 1/4. This is 81 to the 1st. That's the numerator. The index becomes the denominator of my rational exponent. So 81 raised to the 1/4 power equals 3. Okay, so it's correct. So what we're going to do for the most part today is we're going to take expressions and we're going to work with rational exponents and radicals, and we're going to change them back and forth depending on the situation. So for example, number 1, it says change from radical to exponential form. Well, the square root of 3, that's 3 to the 1st. Now the index, when there's nothing there, it's a square root, it's a 2. So we can write that as 3 raised to the 1/2 power. 1/2 is our exponent. And that's it. The 9th root of x to the 4th is x to the power. The exponent 4 becomes the numerator, and the index becomes the denominator. That's x to the 4/9. It's not x times 4 over 9. It's x raised to the 4/9 power. Now number 3, you have 6xy to the 5th. You have the square root of that. Well, That's 6xy in parentheses. The 5 is the numerator. The index is the denominator. 6xy raised to the 5/2 power. Now number 4, we've got the 2x's outside the radical. So I'm just going to copy that down. That's still 2x. Then this is times, this would be the 4th root of x cubed. We're going to write that as x to the 3/4. Now at this point, think back to when you multiply variables, what happens to the exponents? Well, you add them. So we could actually keep going with this. We could simplify this. We would add 1 plus 3/4. Now when you add fractions, so 1 plus 3/4, you need to have a common denominator. In this case, I'll use 4. This is like 4 over 4 plus 3 over 4, which is 7 over 4. Now, if you don't want to go through that process, you can certainly take the calculator, do 1 plus 3/4, which gives you a decimal, and then you can change it, math, enter, enter to a fraction. There's your 7 over 4. I like to do it by hand myself. So this is really 2x raised to the 7/4 power. That's simplified here. Depending on when you do your worksheet, when you're working problems, the way that you answer it really depends on how they ask you to do it. They may ask you to simplify and they may not. So for number 4, yes, we've changed this to a rational exponent, but now we're going to finish it off by combining these terms. So we add the exponents, 2x to the 7/4. Okay, now the next section, we're going to go the other way. Change from exponential to radical form. So let's write this using a radical. So number 5, x to the 3/2 power. The bottom number becomes the index, so it's going to be a square root. And then that's x to the 3rd power. Now if you want, you can write it as square root of x, and then you can put the 3 outside parentheses. Now we can actually simplify this. We can keep going. If you wanted to take the square root of x cubed, we could think of that as square root of x times x times x. You could pull out x squared is a perfect square, so we pull that out, and what we end up getting is x square root x. And that's a good answer. Okay, for what we're doing for our purposes, this is fine. Either of these is fine, unless they tell us to simplify. Number 6, this would be the 5th root of x squared plus y squared raised to the 3rd power. All of that raised to the 3rd. Again, we could just write that as the 5th root of x squared plus y squared raised to the 3rd outside parentheses. They're the same. Number 7, let's write that as one radical. Now notice that both are 3/4 power, 1/4 power. So the index is 4. So we get the 4th root, that's y to the 3rd, z to the 1st. And that's a radical form. Number 8, if you have a negative exponent, first thing we'll do, I'm going to write that with a positive exponent. Remember that the rule is when you have a negative exponent, we can write the reciprocal, that's 1 over a to the positive 2/3 power. 1 over a to the positive 2/3. Okay, now I'm going to take that, that's 1 over, this is going to be a cube root of a to the 2nd. Now again, we could simplify this, but for now, let's just leave it like it is. 1 over the cube root of a to the 2nd. So if you have a negative exponent, you want to convert it first, and then go ahead and change it into radical form. All right, let's flip it over onto the back. So now we'll simplify a little bit here. If you're just dealing with numbers, for example, 27 to the 2/6 power, first of all, let's reduce that fraction. That's 27 to the 1/3. Now, when you're simplifying this, it's easier if you change it into a radical form. So this would be the cube root of 27, and actually that's a perfect cube. That's going to be 3. Now we could check it. We could take 27 raised to the 2/6 power, that's the original problem, should give us 3, and it does. Okay, so everything is good. For number 10, negative 32 to the negative 4/5 power. First off, let's write this with a positive exponent. So what happens, I'm going to write the reciprocal, that's 1 over negative 32 to the positive 4/5. Now we're going to change it. Let's write it as a radical. That's the 5th root of negative 32 to the 4th. Now this is where it's an advantage to put that exponent 4 outside parentheses. The 5th root of negative 32, that's actually a perfect 5th. It would be negative 2. This value would be negative 2. So what we get is 1 over negative 2 to the 4th power. Now negative 2 to the 4th is 16. That's negative 2 times negative 2 times negative 2 times negative 2. So we get 1 over 16. That's the answer. If I want to check it, negative 32 raised to the negative 4/5 power, 0.0625, math, enter, enter. There's my 1 over 16. Okay, so it works. All right, now number 11, we're dealing with variables here and coefficients. Let's multiply the coefficients. Negative 5 times 3 is negative 15. When you multiply variables, x, we add the exponents, 5/3 plus negative 3/4. Now again, you can do this on the calculator. I'm going to kind of come up here and work this. A common denominator is 12. So 5/3 I would multiply by 4 over 4. That would give me 20 over 12 plus, to get from 4 to 12 I'd multiply by 3. So I'd multiply by 3 and 3. We get negative 9 over 12. Now I can add my fractions. I get 11 over 12. And so the answer, we get negative 15 x to the 11/12. Now it doesn't tell us whether to leave it as a rational exponent or a radical, so this is good. If you wanted to write it in radical form, so this is exponential, radical would be negative 15 times the 12th root of x to the 11th. So this right here would be radical. Okay? Number 12, the 9th root of b to the 3rd. What I'm going to do is convert that to rational exponents. That's b to the 3 over 9, which reduces to 1/3. And again, we can leave it like that, or we could write that as the cube root of b. So you can actually simplify this and write it as the cube root of b as a radical. Number 13, 2x minus 1 to the 4/3 times 2x minus 1 to the negative 1/3. So the 2x minus 1 is the same. Think of that as 2x minus 1 raised to the, that's 4/3 plus negative 1/3, which is just 3 over 3. So 2x minus 1 to the 3 over 3, which is 1. So it's just 2x minus 1 to the 1st power, which is 2x minus 1. All right, the last couple here, number 14. When you divide variables, you subtract the exponents. So this will be, the base is x minus 1, that stays the same. That's 1 minus negative 1/2. 1 subtracting negative 1/2, it's minus a minus, both become positive, and that's x minus 1 to the 3/2 power. That would be your rational exponent, and we'll leave it like that. Number 15, the cube root of the square root of 125. I'm going to work this from the inside out. That's the cube root of, okay, 125. The square root of 125 is 125 raised to the 1/2 power. Now if I want to change that to exponential, to rational exponent, the cube root is the same thing as 1/2 divided by 3. This looks kind of weird. 1/2 divided by 3 is 1/6. Okay, so that's 125 to the 1/6 power. Now one thing that you might recognize though is that 125 is really 5 to the 3rd. So 125 is 5 cubed to the 1/6. When you raise a power to a power, you multiply those, you get 5 to the I don't need parentheses, 5 to the 3/6, which is 5 to the 1/2, and that's a good answer. Or you could write that as the square root of 25. And that is the end of the notes.